Right, welcome to the Assessor chapter 21. This is page 323 and this is question 2. So the diagram shows the graph of the equation y equals 6 over x, obviously a 1 over x type graph, reciprocal graph, characteristic shape, 2 branches as follows, and we're going to use the graph to solve these equations. So 6 over x equals minus 3. Okay, so y equals 6 over x and y also equals minus 3. So let's just draw on the line y equals minus 3 and see what we've got. That's y equals minus 3 clearly. I know we don't need all of that, and just read up as follows. That's where we meet, and so there's our solution, x equals minus 2. Now, no mystery there. I mean, 6 divided by minus 3 is minus 2. Just rearranging the equation there, so x is minus 2. Next one, 6 over x equals 5, so the line y equals 5, and let's just draw that in so it looks good. Straight across there, label up to show Mr. Examiner what my brain's just done, and the solution, read it down, looks like 1 square after the 1 to me, so I'm reading down, and that's going to be 1.2. No surprises there. 6 divided by 5 is 1/5, and a fifth is 0.2, hence 1.2. So I know these are both right so far. This one's a little silly. 5 minus 0.5 is of course 4.5, 4.5. So essentially I've got 6 over x equals 4.5, and therefore I'm going to plot the line of y equals 4.5. That's what I make it anyway. So 4.5 on my rough diagram is about there. Let's just cut it a bit short so I can label carefully. Y equals 4.5. Now read down as follows. Probably just 1 square along from the 1.2. So if that's 2 squares long, it's going to be 1.4. So, excuse me. Right. Explain why you cannot find a solution to 3 over x equals 0. I think that's supposed to say 6 over x, honestly. I really do. Because the whole, just rub it out. The whole question is about 6 over x. How about I take this little white thing here and write over it in white so it doesn't really exist anymore, and craftily come over here with black and put a 6 there and pretend that's what they really needed. Yes. So why can't you find the solution to 6 over x equals 0? Well, the line y equals 0, as you're aware, is the x-axis here, and the graph does not at any point pass through the line y equals 0, hence there is no solution. And that's it. That's all you have to say about that. I'll then pause and make some preparations for question 2. Question 2 then. This diagram shows the graph of sine x for values of x from minus 360 to plus 360. In other words, we've got y equals sine x there, and please note that just like the cos curve, it's still cyclical, or rather circular, but it has no line of symmetry about the y-axis, so it's going to be a lot harder to interpret where this is with our extra little diagrams. It says use the diagram and your calculator to find all the possible solutions of these equations, that's these 5 equations here, and all the answers you can get between minus 360 and 360. Okay, first let's just work out one of them, this one right here. If the sine is 0.9, let's just work out what the angle is going to be first of all. So I'm going shift sine 0.9, and I've got 64.2 degrees. Okay, so my first solution is going to be 64.2. 64.2 degrees is the first solution. So that will be around here somewhere, I'm guessing, about there. So if we're going to go 0.9 right across with our facility there, roughly like that, we can get a solution there. We get a solution around there. We got the solution there for 64.2. Of course you can't read it off the graph, but we used our calculator to cite where it's going to be, and these are the 4 solutions. So now what I've got to do is actually work out what these 4 are. Well, we've got one of them, haven't we? So let's just turn over and draw a little diagram. Forward. Right, just add a page. Right, one of these beautiful things. So follows. Remember how these go? These go 0 degrees, 90 degrees, 180 degrees. Again, anti-clockwise is the positive direction, 270 degrees, and back to 360. And the first solution is that one right there, and that was 64.2 degrees. Alright, so sine is positive there, and sine is positive there. Therefore, the other relevant solution is going to be this angle here, which is going to be 180 take away the 64 there. So if I write it in as follows, 180 take away the 64.2, and we're going to get a solution again. So 180 minus 64.2, and that gives us 115.8. So here's our next positive solution, 115.8. And then the only two that are positive angles. Now, let's just see what we've got. Yeah, 115, that's about right. So let's just write that one in blue. 115.8. I probably won't have a space to fit them all in there, but that's my problem. Next one. In order to match this position again, I can start from this position and go clockwise like that and land right there. Okay, so we've got 90, 180 plus the extra 64.2, so I've got 180 plus 64.2 going in the clockwise but negative direction. So here we go, 180 plus 64.2 gives us a solution of 244. It's barely visible, let's go yellow. So you've got 244.2 degrees, and that's my next solution there. Let's write it in blue, 244.2 degrees. These are all degrees, of course. Don't have an awful lot of space, do we? Right, next one. The only valid solution would be, again, starting from 0. Watch me. 90, 180, 270, and stop right there. Essentially, we've got 360 degrees. Take away the 64.2. So 360, take away the 64.2. Let's just work it out now. And that gives me 295.8. And these are our four solutions: 64.2, 115.8, 244.2, and 295.8. So let me just write it in. 295.8 in blue. 295.8. Four solutions. I'll pause there and check I've not made a mistake. Of course, these should be negative because I'm going in the negative direction, so I've made a mistake in that sense. So this one's going to be minus. Just put a minus in front of that, and this one's going to be minus as well. So it'd be negative 180 plus 64.2. So they're the four solutions in that sense. There was a mistake there. Right then, that's that. Then I've got to do the same with minus 0.5. Okay, well, if I try and remove some of this, it might help me just to see my four solutions. Or if I draw one of these in as follows, in red maybe. So minus 0.5 will be about here somewhere. And either way, we're looking at four solutions. 1, 2, 3, 4. So we're looking at something between 180 and 270, between 270 and 360, and between 0 and minus 90, between minus 90 and minus 180. So I've got to draw a separate little grid for that one, as follows, if it lets me. Good. Right. One of these down here then. Let's get the most basic solution going, and that will be sine of minus 0.5. So if I go shift sine, open my bracket, minus 0.5, close my bracket, I've got minus 30 degrees. Okay then, minus 30 degrees it is. So first solution, minus 30 degrees. Next one, let's just draw the little grid in position then we can start putting angles in it. Minus 30, that's 30 there. So first let's cite where sine is going to be negative. Well, sine is positive there and there, so we're looking for solutions here and here. So there's the first solution, minus 30 degrees, and therefore the next solution would be in this third quadrant here, going anti-clockwise as follows, and stopping right there. So we're looking at 180, take away 30, but of course it's going to be a negative solution, so that's going to be minus 150 degrees from 0 degrees here past the 90 mark. Well, it's minus 90, isn't it? Then coming on to 180, then adding on an extra little bit of 30 to go back up to 150. So it's minus 150 from the diagram. And that's our second solution. Next one, well, we have to go in the positive direction. We have to go like this. Let's make it stand out in red. We go like this and stop in this position. Here we go. Go like that and stop. We've essentially got 180 degrees plus the extra 30. So I'll do that in red. 180 plus 30, and that's going to give us a positive value of 210 degrees, and that's positive, so we've gone anti-clockwise. So 210 is our next answer. And the last one, using red again, all the way round, 90, 180, 270 and 360 minus that little bit of 30 there. So you're looking at positive 330 degrees, and that's the other solution. We'll do this as the last one, then maybe pause the video, as it's getting really long, isn't it? So next one, point 2. So I want to know shift sign point 2 and then get the first basic angle. So shift sign of point 2 gives me an angle of 11.5 degrees to 1 decimal place. So it's 11.5 is the first solution. Again, let's set up another little grid. Start a fresh page, I think. We're good. So we're playing with 11 degrees essentially, aren't we? So let's make it look nice and thin and skinny. So it's 11.5 and it's a positive sign. Then sign's going to be positive in this quadrant and this quadrant. So here we have 11.5, the first solution going that way, and the next solution would stop just there. So you're looking at 180 degrees. Take away the 11.5, and that will give us an answer. And 168.5. So 168.5 degrees is the second solution in the second quadrant. Alright. Again, the only way to match the corresponding angle for 11.5 and 168.5 is to work in the clockwise but negative direction. So let's make it stand out in red. We'll do this one here first. So here we go. 90, 180 plus that extra 11.5. So it's going to be a negative answer. So it's going to be minus 180 plus the 11.5, and that will give us a negative answer of, so 180, oh I can do that, 191.5, so it's negative 191.5. Let's write it in. Okay, and what was the other one I didn't write in? Oh, the 168.5, just put it in. So it's all complete. And we'll have the last one now. The last one's going to be all the way around here in red. We're going to go 90, 180, 270 and all this, almost 360. We're going to take away the 11.5. So this one's going to be 360, take away the 11.5, and the answer will of course be negative because we're going clockwise. So 360 take away 11.5 gives us 148.5. In other words, 348.5 minus 348.5 degrees is the final solution. And I'll stop the video there, and I'll use the remaining time to do part 4 and 5 and do part B as well.